Okay, for the setup process, the first thing I want to do is bring in a vector line of an oval and resize it to fit my stock. My stock in this case was 7 inches tall and 3/4 of an inch thick. So I'm resizing this oval to be less than 7 inches tall, and then just pulling out the horizontals until I think it looks decent. This is going to be the outline of our tray. Next thing I'm going to do is make another oval that's slightly smaller to fit inside. This will be the boundaries of where our hollowed out tray part is going to be. I wanted a 1/2 inch border around both, so all I had to do was change the sizes to be a full inch smaller because it measures across the diameter. Then I select both ovals and I can align the centers so that they are perfectly concentric. So next I'm going to add a third oval. This one's going to be half the distance of both, and this is going to make a small channel for an inlay I'm going to attempt. And yet again, we're going to align all the vectors so that everything is perfectly concentric. So now we've got the basic line drawing of our tray. So toolpaths is where things go 3D. This is a pocket toolpath. So I select which line I want the pocketing tool to follow. It's a 3/4 inch round nose bowl bit with a 1/4 inch radius. And knowing that our stock is 3/4 of an inch thick, we don't want to go all the way to the bottom, so we're going to leave an 1/8 inch of material. And there's our toolpath for the bowl part of the tray. So this is the channel for the inlay. It's a simple contour, it just follows the line exactly. It's a 1/16 inch bit, and I only want it to go down half the diameter of the wire I intend to inlay. So in this case it was a 32nd would be half the diameter, because the diameter of the wire was a 1/16. And I want it to ride directly on the line, so no offset. We'll go ahead and rename this, I don't remember, inlay. And then the final oval is the outside edge. So we're going to do another contour. In this case, we're cutting out with a 1/4 inch end mill. And I want it to be outside the line. I don't want it to go into that line. Go ahead and rename this cutout. And this is tabs. This keeps the piece from separating from the stock after it's cut out, because if it separates, it'll wedge the cutter in there and it'll break and snap and burn, and it's really nasty. So I'm placing 6 tabs. It doesn't really matter where you put them or what you do with them as long as they're there. And that's the end of our setup. Here's our preview. This is in aluminum right now, but we're going to be doing it out of wood. We'll take a pan around, check out the tool paths, and decide, hey, you know what, that looks pretty good. That's what we're going to go with. Get rid of the tool paths so we can get a better look at what the finished product is going to look like. Okay, here's just a little look at what my setup looks like. I use a tablet to send the G-code. It's set up on a wireless network. The first thing I do is put some blue painter's tape down on my spoil board. You can see I've got a grid laid out. That's so I know where to place the stock 90 degrees true to the cutter itself. So all I have to do here is slap down some blue tape to completely cover the area where I'm going to be placing my stock. This will make a lot of sense in just a minute. After this, we'll put blue tape on the back side of the stock. I like to completely cover it. Some people don't. It doesn't really matter either way. Same idea here, just completely lay out the bottom of your stock with your blue painter's tape. Ta-da! This is where the magic happens. You take some super glue. I like the Gorilla gel glue. And you put it on the tape that's on the back of the stock. This allows you to effectively glue your stock to the wasteboard without actually gluing your stock to the wasteboard. It doesn't take a whole lot, just a couple dabs here and there. Then I line it up so that it is aligned with the grid that I've cut into the wasteboard on both the X and the Y axis. And then I clamp it down with some buckets of paint just to hold everything in place while the glue dries. Then we initialize the machine. This allows it to find its home position. This is machine home, so it moves completely to the top right of the X and Y axis until it hits the limit switch and it says, okay, I'm home. Then it pops up front and it wants a tool. There's already one in there, but we got to put the right tool in. So this is the 3/4 inch bowl bit with the 1/4 inch radius. This thing hogs material out. That's why I like using it for the insides of this. Plus it gives it a nice shape. So we'll go ahead and fasten that into the collet. And this is the bit setter. It basically tells the machine how long the tool is. It comes down on the Z-axis and presses this little button, and once it makes the switch, it's able to calculate how far down it moved to make that switch. So it knows where the bottom of the tool is, where the top of the stock is, and where the bottom of the stock is. So now we need to tell it where to start the project. By default, this is typically in the front left corner, so we'll manually jog it over on the X and Y axis and then bring it down to just touch the top of the Z axis. You use a piece of paper so that you don't drive completely into the wood. You can get a precise location. Okay, so next all you got to do is set your 0. This tells it, yes, this is in fact where I want you to start the project at. Okay, next we're going to tell it which project we want to use, so we'll load the file. And we'll select our oval tray CNC code, G code. It's going to load that into the program. And then we're going to start the job. Now the first step of every job is to load a new tool. Thankfully we've already done that, so we can skip that portion. Okay, next we're going to slap on the dust shoe. It's basically a brush hooked up to a vacuum, and it just keeps wood chips and sawdust from getting all over the place, because then Alyssa gets upset and it just makes a humongous mess, huge mess. After that, you're off to the races. This is real time. You can speed up the feed and the rotational speed of the cutter, but I'm just gonna kind of do a time-lapsey type deal here so that you don't have to sit through 40 minutes of machine cutting. That's kind of boring. So for our next operation, this is the bit we'll be using. It's a 16th inch diameter. In this case, I went ahead and left the dust shoe off just so you could see well, what it looks like when it's cutting. Then to cut it out, we're going to use this 1/4 inch flat nose 3-flute carbide end mill, just because. And we'll just go ahead and lift the rest of the stock away since it's been completely cut away from the actual part itself. And hit the fuzzy bits with some sandpaper real quick just because it's fastened down and nobody likes fuzzy bits. Next I'm going to torch the wood. Only parts of the grain burn, so it really brings it out. It's a Japanese technique called shoshugiban. This is after a lot of hand sanding. I went to 320 grit, and then I hit it with a dark walnut stain, wiped it off pretty quick. This is when things really started to go wrong. I super glued some aluminum wire into that channel I cut, and I ended up just getting glue everywhere. It was such a disaster. But here it is, and I had to take a file and take off the top half of that wire to make it flush with the top of the wood tray. It turned out pretty cool. I'll show you what it looks like.